Hi guys, these are our notes about key features of the sine and cosine graph. We got a new little digital notebook just for this week. You can fill in the table of contents. You could honestly put both of them in right now, but we're going to be on slide 6 and 7 today, talking about key features of the sine and cosine graph. You should have already taken some notes. These notes you had to write down for homework the night before, and then in class we took the rest of our notes and did the examples. So you looked at kind of a discovery little lesson on Desmos about the sine graph. We didn't get to go over the cosine graph, but the cosine graph looks just like the sine graph. When you graph them, they make the same little repeating curve. It's just the cosine goes from max to max and the sine goes mid, max, mid, min, mid. So the key features of the graph that we're going to look at today are amplitude, midline, period, and frequency. We have the definition of those. So now we're going to see how to determine them from a graph and how to determine them from an equation. So go ahead and you should have hopefully already written down identify key features. So when you're talking about a sine graph, okay, a sine graph starts at the midline, it ends at the midline, halfway in between it's a midline. Quarter 1 you're at a max, and quarter 3 you're at a minimum, and this is like our sine graph. And then a cosine graph starts at a maximum, ends at a maximum, halfway in between is at the minimum, and then quarter 1 and quarter 3 are at the midline. So we have sine and cosine. So this one is sine, this one is cosine. So the one of the key features that you're going to have to find is the midline. So the midline is just the middle of your graph. It's the line y equals k when we talk about the equation. But the midline is directly in between the minimum and the maximum. The distance from the midline to the maximum, or the midline to the minimum, this is the amplitude when you're looking at a graph. So from maximum to midline, or midline to maximum, those are just your amplitude. The period is how long it takes. It's the horizontal distance to complete one cycle, one curve. So for cosine, that's max to max. For sine, you have to hit all 5 critical points. And then the frequency is just the flip of the period. It's just how many cycles per unit. So you just flip the period to get the sine or cosine. From the equation, so our equation is y equals, or f of x, I guess I should say function. I think most of our problems do it as a function. F of x equals a sine b x minus h plus k. Or f of x equals a cosine b x minus h plus k. All right, so to be able to find the amplitude from the equation, so we kind of had this on our little discovery activity yesterday, is the number in front of sine, or cosine is your amplitude. Just going to abbreviate it with amp. So they're the same. The k value is your midline, whatever you're adding at the end. I should say midline. Your b helps you find the period, but b is not equal to the period. The period is equal to 2 pi over b. And the last thing that we hadn't talked about so far is that h. Your h, I don't have a whole lot of room, ran out of room, is our horizontal shift. It's how much we move left or right. And it's always the opposite sign. So if you have an H, if it says -2, it's really a +2 shift. If it says a +7, it's really a -7 shift. You would go to the left. I don't think any of our problems give us the shift today, but we'll talk kind of more about that tomorrow. All right, so that's it for our little notes part. Now we're going to go do some examples so you guys can see it. You already saw a little bit yesterday, so hopefully this should look a little bit familiar. So this is in our workbook from page 87. We're still in Unit 3, page 87. Your problems and your examples all ask for you to find the period, frequency, midline, and amplitude. Most of your homework problems just ask for those 4 things. Period, frequency, midline, amplitude. So you don't have to go in order, okay? It says period, frequency, midline, amplitude. I don't suggest going in that order. My suggestion would be to find the midline first, then the amplitude, then the period, and then the frequency. That would be like my order of what I would go in when I'm finding them. So to find the middle, you just look, okay, well, the top is at 1, the bottom's at -5, and you just find what's halfway in between those two. So that's a distance of 6. So halfway in between would be right here. So that means my midline is right here at -2. So my midline is the line y equals -2. So your midline will always be y equals. So your midline is y equals -2 because you hit the y-axis at -2 for your middle. Then next thing I'm going to do is find my amplitude. My amplitude is the distance from max to midline or minimum to midline. Either one should be the same. So it's just half the distance from max to min. So my amplitude here is 3. Then I'm going to determine my period. My period is how long it takes to complete one curve. So I start at the midline. Okay, so that means it's a sine curve because it starts at the midline. You go up to the maximum, down to the midline, down to the minimum, up to the midline. How far is that horizontal distance that it took? So how far did it take us to complete one curve? It took us 2 pi to complete one curve. The horizontal distance to get to those 5 critical points was 2 pi. Your frequency, in order to get frequency, you just flip the period, right? So if you flip 2 pi over, well, there's nothing there, so it's a 1. So when you flip it, it becomes 1 over 2 pi. That means you have one curve every 2 pi distance. So there's a distance of 2 pi, you only fit in one curve. So sometimes it's actually easier to find the frequency first and then the period. I'll kind of show you an example of that. So I didn't go in order of what they gave me. They said period, frequency, midline, amplitude. I did midline first, then amplitude, then period, then frequency. We're going to do some more examples so you guys can see. Okay. All right, example 2, same thing. Find the period, frequency, midline, amplitude. I'm not going to go in that order. I'm going to first find my midline. Okay, that's the one that I'm going to find first. Do midline, then my amplitude. Okay, so when I do my midline, okay, I find, this is at 1.5 and this is at 0.5. So what's directly in between those? So my midline is right here at 1. So since my midline is at 1, right, my midline's at 1, then my equation is y equals -1. I'm sorry, y equals +1. So y equals, and then whatever number you hit at. Then your amplitude is your distance from midline to max or minimum to midline. It should be the same. And if you look here, it's not a distance of 1. You go up to 1 and 1/2 and down to 1/2. So my amplitude is just 1/2 or 0.5. Either way, it's fine. Then I'm going to try to determine my period or frequency. Okay. All right, so the starting point right here is at maximum, right? My starting point's at a maximum. So this means it's a cosine curve. Since it starts at the max, it's a cosine curve. The period then is the distance from max to max. Well, when I look down here of how long that horizontal took, there's no number there. So there's no official number right here, right? So it's a little hard to tell. So instead of doing the period first, I'm actually going to do the frequency first because I can't easily see the horizontal distance, okay, max to max. There's no value right here, so I can't as easily see it. So instead, I'm just going to count how many curves until I get to like a nice little piece on here. So I have one curve, right? That's one cosine curve. And then max to max would be 2 cosine curves. Well, that didn't land anywhere nice for me either. So then I go max to max, that would be 3 cosine curves, and it did land somewhere nice, right? It landed at 2 pi. So that means I did 3 curves over a distance of 2 pi, right? There was 1 curve, 2 curves, 3 curves. I did 3 curves over a distance of 2 pi. That is the frequency. Then to find my period, then you would just have to flip it, and it would be 2 pi over 3 is my period. That's how long it took to make one. So here's 2 pi, and then if I broke it into thirds, right? Here's 1/3, 2/3, 3/3, right? So 2 pi broke into thirds. That's how long it took to complete one sine curve. So sometimes it's easier to find the frequency first if it doesn't land nice and neatly, right? So it went max, oops, I need to do that. It went max to max. That's one curve, but this distance right here, there wasn't like a nice number here for me to know what it was. So that's when I went ahead and did frequency first. Okay, so from a graph, find your midline first, then your amplitude, and then you can go back and find your period and frequency. They're just reciprocals of each other. All right, example 3 says determine the period, frequency, midline, and amplitude of the function. So when we're doing this problem, okay, they gave us an equation instead of a graph. So some of your homework problems are going to do that as well. So in an equation, okay, we have f of x equals a, this is a cosine equation, so it's a cosine. This is a little equation I gave you guys. Okay, so a cosine b, x minus h plus k. So we got to decide like what our pieces are. So the number in front right here would then be our a. So what does a stand for in our notes? A is the amplitude. So our amplitude is 2, right? So we're finding period, frequency, midline, amplitude. I'm going to do my amplitude first, and then I'm going to do my midline. Your midline is whatever is being added or subtracted outside your parentheses usually. H is always in parentheses, so if there are no parentheses, then it's probably just a K. But this value out here then would be my K. And that's my midline. So my midline is the line y equals -4. And then the next thing I have to find is my period and frequency. So in order to find the period, you use B, but B and the period are not the same thing. So in this case, they put B inside the parentheses. Over here, I had B outside the parentheses, but B is always in front of X. If I did distribute this, it would just be B times X, so then it would be inside the parentheses. So the period is always 2 pi over B, and B is 1/3 in this problem. So it would be 2 pi divided by 1/3. Well, in order to divide by a fraction, we keep, change, flip. So I keep my 2 pi, change it to multiplication, and when I flip 1/3, I get 3. 2 pi times 3 is 6 pi. So my period is 6 pi. That's how long it would take to complete one curve. A distance of 6 pi would take to complete one curve. And then lastly, to get my frequency, I would just flip the period. So to flip 6 pi, that's 6 pi over technically 1, so it'd be 1 over 6 pi. You complete one cycle, one curve in 6 pi distance. All right, I've been forgetting to like put box around my answers, but those are the 4 things that they've been asking for. All right, last example, number 4 says describe the difference between the function 3 sine x minus 1 in parentheses and the function 3 sine of 2 x minus 1 in parentheses, but there's brackets, okay? So when I look at my problems, right, they both have the same a value, both have the 3. They both have the same h value, okay, this is h. So I have the same a, which is the amplitude. They have the same h, which is the horizontal shift, but what they don't have the same is this b value right here, right? This one has a b of 2, and this one, there's nothing there, so this is a b value of 1. Well, what does b affect? B affects the period. So for this one, has a period of 2 pi over 1, because that's what b is, and this one has a period of 2 pi over 2, because that's what b is. Period is 2 pi divided by b. So here the period is 2 pi, and over here the period is pi. That's the distance it takes to complete one curve. So if I was, graphing, and here's 2 pi, the first one, it would take a full 2 pi to complete one curve. The second one, it would only take till pi, which would be halfway in between. So it would only take this distance to complete one curve. Well, they have the same amplitude, so it should go the same distance. Okay. So the question was, describe the difference. It just, one's f of x, right? One's g of x. F of x's period is twice as long. It took 2 pi to complete a curve, and g of x only took pi. So the difference is f of x's period is twice as long. And those are all of our examples. So for your homework tonight, you're going to be on page 91, 1 through 10. It's going to ask you to determine those same 4 things. So midline, amplitude, frequency, period. Don't have to do them in order that they give you, period, frequency, midline, amplitude. I usually do the midline first, if it's a graph, and then the amplitude, and then do period, frequency. And then if it's an equation, I do amplitude, and then midline, and then period and frequency after. Okay, all right, so where it goes into your digital notebook is slide 6 for the little notes part that we took on Monday and Tuesday, and then page 87 and 88 go on slide number 7, and that's it.